Hello, I'm Mr. Muskeluk, your AP Chemistry teacher at ChemAdvantage.
This is a problem in one of the assignments, and I'm going to explain it. The numbers are a bit different than the problem, so you'll get a chance to do the problem on your own. Acids react with carbonates to make carbon dioxide and water. That statement's worth remembering. It allows you to identify a carbonate and also tells you if the substance you have is an acid. In fact, here's a short video showing an acid reacting with a carbonate. A nice quick test. You get that fizzing of CO2. Here are the balanced reactions of sodium carbonate with these two acids. Here's two acids. Sulfuric acid, it reacts with sodium carbonate, of course, and we've got our CO2 fizzing away as a gas, some water, and the sodiums are there with the sulfates as spectator ions. Hydrochloric acid does the same thing, except you'll need 2 moles of hydrochloric acid for 1 mole of the carbonate. These two hydrogens are required. Our sulfuric acid is one of our double acids. Let's continue with the problem. In trying to identify if an acid was either H2SO4, sulfuric, or hydrochloric, a 40 ml sample of the 0.120 molar acid reacted with excess sodium carbonate. So we don't have a limiting reactant, but we have a volume and a concentration of this acid, whether it's sulfuric or hydrochloric. Carbon dioxide gas was collected and found to have a volume. Okay, we have a volume and a pressure and a temperature. Well, we've got a couple of things here. We've got a volume and concentration of a solution, and we have a specific amount of carbon dioxide gas. Let's see what the questions are. How many moles of acid were used? Well, we've got an acid and we have a concentration and volume, and we know that that's a pretty straightforward arrangement where you multiply the concentration times the volume to give you the amount. That's something just like changing grams into moles and moles into grams, you should have down pat for AP chemistry. So this will be a multiplication that is going to provide our volume. Now I'm just going to multiply the moles per liter, which is the concentration, times the milliliters. We've got the 0.12 molar, 120 millimolar, and volume in milliliters. If we multiply these two, the liters cancel, and we get millimoles, which is nice because if we did it in liters, you'd have a decimal point and 2 zeros and a 4/8. Let me just double check that. I'll pull my calculator out and do our 40 times 0.12. That way we'll sure we've got the decimal point right. And yes, 4.8 millimoles. I'll write that down. And don't forget that little millimole in there. It's the thousandths of a mole. Or if you want, you could have written 0.0048 moles of HCl or H2SO4. We're not sure which one it is. Either one. How many moles of carbon dioxide gas could be produced by the sulfuric acid based on the stoichiometry? Well, here's our H2SO4, 1, and here's our CO2, 1. And we know a 1-to-1 relationship. If there's no limiting reactant, they're going to be the same. 1-to-1, and this will be an easy answer, the same 4.80 millimoles of CO2. Next, we'll figure out the same thing for the hydrochloric acid. How many moles of carbon dioxide produced by the hydrochloric acid that we know we have 4.8 millimoles of would produce our CO2? Well, here's our relationship, 2 HCl's and 1 CO2. We only get half as many moles of carbon dioxide as we have moles of acid. So we would divide that by 2. That's the number of moles that we have. No need for a calculator on this. 2.4 millimoles of CO2. So we're going to have a difference in terms of how much carbon dioxide is produced depending on whether it's sulfuric acid or hydrochloric acid. Now, the question says, based on how many moles of carbon dioxide were actually produced, which acid was used in this experiment? Well, we can figure out the moles of carbon dioxide and see which one of these two it matches. So we'll use our standard arrangement. We know how to figure out gas moles because we've got pressure, volume, the gas constant, and temperature. This, again, should be in your arsenal of things that you've got that you can access immediately, because moles are asked for a lot when we deal with gases. It doesn't matter what the gas is. If you know its pressure, volume, and you know the gas constant and temperature, you've got the number of moles. And we can just set this up by plugging in all the values. Here's the AP equation sheet, page 1, and as you can see, the equation sheet's divided into different topics: atomic structure, equilibrium, kinetics. Page 2, gases, liquids, and solutions. It's got quite a few equations in it, and here's the important one, where we have our gas constant. Be careful. This gas constant is used for energy. It can also be used as a gas constant if we had our units for gases in metric units, but we don't. We use atmospheres and liters. So this one will be used. If you've got something that requires joules, then you'll use this. Here is the one that we prefer to use, 0.08206 liters, atmospheres, moles, and Kelvin. They provide one that gives you moles in liters and torr, but I advise using against this one. This one is sort of unusual. Most colleges just end up using these two. If you're really good with units, yes, use this, but I warned you. So let's go back using this gas constant with the data that we had for this question. This version of the gas law, PV over RT, gives us moles. We're going to be using the gas constant that I said is preferred to be used, which is the 0.08206 atmospheres and liters and moles Kelvin. So we'll have to remember that our pressure, volume, and temperature are going to match these units. And if it doesn't match, well, no, there's going to be something we have to deal with. Well, for our atmospheres, our P, we are given 696 millimeters of mercury, or torr. AP uses both of these, a non-standard unit, but that's the one that they use. And to change that into atmospheres, we divide by 760. So this is going to be that 696 divided by 760, and this provides us our atmospheres. And again, this is something you've got to remember for AP Chem, changing torr or millimeters of mercury into atmospheres. Now, our volume should be in liters, but I'm going to make a little twist here. I'm still going to keep the milliliters. If we use milliliters, our answer, instead of being in moles, will be in millimoles, which is great. That's what we have here. Again, nice number. You could use liters, but then we've got to go to 0.0, whatever it is. So if you're clever, you know milli, use them. Use them to your advantage. And of course, we have to have our temperature. And remember, no matter what, our temperature has to be in kelvins. If you have degrees Celsius in a gas law problem, undoubtedly you'll change that to kelvins. And that's something you should remember too. It's given on the AP equation sheets, but this is something you've got to memorize if you want to do well on the AP exam. Well, let's get our calculator out and do that calculation. Here you can see the previous calculation where we found out the amount of carbon dioxide that could have been produced by our sulfuric acid. Now we're going to find out the amount of gas, carbon dioxide, that was actually produced. We can just do our calculation continuously in here. Do a 696 divided by 760. That will give us our atmospheres. We'll multiply by 128, which is our milliliters. So we'll get millimoles. And we'll divide by our gas constant, 0.8206. That's there. I'm going to divide this into here. So this is the division. So I'll divide by the temperature. I better put that in parentheses because it's an addition. 273 plus 25. I'll close the parentheses. So I have these two multiplied, divided by the gas constant, divided by the Kelvin temperature. Let's see if we get 4.8 or 2.4 moles. Enter. 4.8. That's the number of moles of gas that are present. We can just say, okay, 4.79 was the actual value on the calculator. And that matches the sulfuric acid with a 1-to-1 molar relationship. Had this been hydrochloric acid, we would have produced half as much carbon dioxide because compared to sulfuric acid, hydrochloric acid is half the acid that sulfuric is. Well, we've solved the problem. If you're doing this problem in my problem sets, then you'll have some different numbers, but you'll know how to solve it. So in solving this problem, you can show your skills in terms of concentration, stoichiometry, and gas laws. A nice way to show your knowledge of chemistry.